In this problem, we're looking at an oil refinery. It's located on the north bank of a straight river that's 1 kilometer wide. A pipeline is to be constructed from the refinery to storage tanks that are on the south bank of the river, so across the river 8 kilometers east of the refinery. The cost of laying pipe, they tell us over land, it's a little bit cheaper than under the river. So to minimize the cost of the pipeline, how far from the refinery should point P be located? So obviously we're going to have to draw a picture of this situation. So we've got our river, and we know the river is 1 kilometer wide, and we've got a refinery I'll call R on the north bank of the river. And we've got storage banks on the south side of the river. I'll call that S. And it says it's 8 kilometers east of the refinery. So that distance is 8. And so the pipeline is going to go, it says laying pipe $400,000 per kilometer over land to a point P on the north bank. So from the refinery, I'm going to stay along the river to some point P, and then we're going to go under the river to the storage tanks. So the path, we're going to have a point P that's somewhere in between here. That's where the pipeline is going to cut down. And so the path of the pipeline, it's going to go from R to P on land, and then from P to S along the river. So I see here I've got a right triangle right there. And so I know this side is 1. I could call this side X, and then this third side, that's the hypotenuse right here. That would be the Pythagorean theorem then I could use to find that. So x squared plus 1 squared would be this side squared. So I would take the square root of x squared plus 1, and that would be that length here. The square root of x squared plus 1 would be that length. And of course, up here, if this total length was 8, this length here, since this is x, this length would have to be 8 minus x. So for my cost, the cost over land, well, first of all, it's $400,000 per kilometer. I'm just going to measure in hundreds of thousands of dollars, so I'm just going to call that 4. So over land along point P, it's $400,000 per kilometer, and the distance is 8 minus x. So the cost is going to be 4 times 8 minus x. Whereas the pipeline under the river, its cost is 6, right? $600,000. And the distance under the river is this diagonal distance, the square root of x squared plus 1. So it would be 6 times the square root of x squared plus 1. And of course, both of these those units are in hundreds of thousands of dollars. So the function Q, the quantity that I'm trying to minimize here, is the total cost. That would be 4 times 8 minus x plus 6 times the square root of x squared plus 1. And if I rewrite this a little, 32 minus 4x, and I'm going to write this with an exponent, so x squared plus 1 to the 1/2, because I'm going to have to take the derivative, right? If I want to minimize or maximize this, I'm going to have to find the critical numbers, which means I'm going to have to find where q is either equal to 0 or undefined. So I'm going to have to take q prime. Well, the derivative of 32 is 0. The derivative of negative 4x is negative 4. For this next part, the 6 goes along for the ride, but I'm going to have to bring the 1/2 down in front. So times 1/2, then I get x squared plus 1 I'm going to have to subtract 1 from this exponent. So a half minus 1, that would be a half minus 2 over 2, so that'll be negative 1/2. And then don't forget, this wasn't just a variable to a power, it was a function to a power. So I have to use the chain rule, and I have to take the derivative of the inside, which would be 2x. And if I clean this up then, I get negative 4. These 2's cancel out. Don't forget that x over there. So I get plus 6x times x squared plus 1 to the negative 1/2. Let's see, if I'm going to rewrite this, this is going to be 6x over the square root of x squared plus 1. If I want to get a common denominator, that's going to happen there. And so in my top, I get 6x minus 4 times this square root. And then that's an x squared, and then x squared plus 1 in the bottom. Now, if I'm going to try to maximize this, I'm going to need to either figure out where q prime, ooh, forgot my square root in the bottom. I'm going to have to figure out where q prime is either 0 or undefined. Where it's undefined is where the bottom would be 0, and that's just not going to happen. The smallest that this is ever going to be is if x is 0, because if x is plus or minus, it gets squared, which gives me a positive number, plus 1. So the smallest this can be is 0 plus 1, and then the square root of that will just be 1 in the bottom. That's never going to be undefined. But I can set q prime equal to 0. So that's going to say 6x minus 4 times this square root is equal to 0. So I'll move the square root to the other side. And then I'm just going to square both sides of this equation. So I'll get 36x squared equals 16 times x squared plus 1, right? A square root squared goes away. I'm going to clean this up a little bit. So I'll subtract 16x squared. I'll divide by 16, and then I can take a 4 out of the top and the bottom. And when I take my square root then, it's going to be the square root of 4/5, which would be 2 over the square root of 5. Now in theory, that should be plus or minus, but the negative answer doesn't really make any sense, so I don't really have to worry about that. I'll just take the positive value of x. Because again, up here x is this distance, so it doesn't make any sense to have a negative value. One thing about this problem that's a little bit different from some other problems is this problem has a definite restriction on the domain of x. X here is this value for this length. The smallest x could be would be 0. That would mean that the pipeline would come all the way across directly opposite the storage tanks and then perpendicularly across the river. But that's the lowest possible value for x. On the other hand, the highest possible value for x is 8. If x were 8, then this value would be 0, which means it wouldn't go along land at all, and it would just go directly across the river. So I know here that my x value has to be strictly between 0 and 8. That means this function q over here is defined on a closed interval. It must achieve an absolute maximum and an absolute minimum on that closed interval, assuming it's continuous. And this function is continuous everywhere. I never take a square root of a negative number, so I never have to worry about continuity. So to really tell if I've got a true absolute maximum or minimum here, I just have to look at q of 0 and q of 8, and then this value q of 2 over the square root of 5. So plugging in 0 and 8 isn't too bad. If I plug 0 in, well, 0 squared plus 1, this is just 1 to any power is 1. 1 times 6 is 6. If I plug in 0 here, that's 0, so I just get 32 plus 6, 38. If you need to, write it down, right? I'm just not writing down the details. If I plug in 8, this part becomes 0. 32 minus 4 times 8, this is 0. But when I plug 8 in here, 8 squared plus 1, that's 65. I get 6 times the square root of 65. If I do that on the calculator, that ends up being about 48.37. So obviously that's not the minimum. So far the minimum is this 38, again that's 3,800,000 dollars because of how I've measured this. And then so I also need to look at Q of 2 over the square root of 5. If I plug that into this 32, I get into this Q function up here. I get 32 minus 4 times 2 over the square root of 5 plus 6 times the square root of 2 over the square root of 5 squared plus 1. I'm going to do this a little quickly. If I square this, I would get 4 over 5 plus 5 over 5 would be 9 over 5. I take the square root, I get that. So this would be 32 plus 10 over the square root of 5. Again, you can fill in the gaps if you need to. And if I look at that, that's about 36.47. And so when I compare the 38, the 48.37, and the 36.47, I see this 36.47 is the smallest. That minimum cost occurs when x equals 2 over the square root of 5. Now it does say I'm supposed to be rounding my answer to 2 decimal places. Notice that the answer is how far from the refinery should P be located? Well, the refinery is here, P is here, so my distance is 8 minus x. So that's going to be 8 minus 2 over the square root of 5. And if you do that on the calculator, that ends up being about 7.11 kilometers. And the cost is, if it was $600,000, the 6 would be in the 100,000 place. So right, this would be basically $647,000. This is $3,600,000. So it would be a total cost of $3,647,000. We didn't need that for this here, but that would be this problem.